Welcome back to another Chemistry Mole video. In this video, we're going to be looking at isomers. Specifically, we're going to be focusing on a type of stereoisomerism known as optical isomerism. So let's just do a quick recap of the types of isomerism that you need to know for A-level chemistry. So as the overall heading of isomerism, you could have structural isomers, which you will have seen in the first year of the course. And there are three types, so positional, chain, functional group isomerism. So positional, where the position of the functional group is moved. Chain isomerism, where you get branching of the chain. And then functional group isomerism, where you have a different functional group. For example, ketones and aldehydes. Stereoisomerism, you'll have seen geometric isomerism in year 12. So that would be EZ isomerism, also cis and trans. Today, we're going to be looking at optical isomerism. So the first thing to do would be to define what we mean by the term stereoisomerism. So stereoisomers, they are compounds with the same structural formula, but a different spatial arrangement of atoms. And under the category of stereoisomerism, we can look at optical isomers. So these are non-superimposable mirror images. Now, one of the best ways to see this is with your hands. So if you place one hand on one side of the page here, the other hand on the other side, you can see that these are mirror images of one another. So your thumb's pointing towards each other. These are non-superimposable mirror images because if you place one hand on top of the other, your thumbs will be pointing in opposite directions. You can't match your two hands up if you place one on top of each other and make them face in the same direction. Now let's have a look at some examples of optical isomers. So let's draw this first molecule here. So we've got carbon in the center. We've got hydrogen. I will place a chlorine on here. We will also have a bromine attached. And we have to have another group here that's different. So we'll place fluorine on this molecule. So the first thing to notice is that we have a center here to our molecule. And this is called a chiral center. We'll go into this in a bit more detail later, but the key thing here is on the carbon atom, there are 4 different atoms attached to it. Now these could be different atoms or they could be different groups of atoms. So there could be a CH3 group here, but the key thing is that there's 4 different ones attached to this carbon here. This means that you can have mirror images of the molecule depending on the direction that the atoms are facing. So we can draw 3D diagrams of these models. Now, if I place a mirror down the center, key thing is how you start off drawing these structures. As long as you start off in this manner, you will always be able to draw the optical isomers and make sure that the atoms are pointing in the correct directions. So the first thing we have here is a wedge coming out of the page towards you. A dotted line here shows that this line is going into the page. So we'll do the same thing on this molecule here. So this one here, wedge coming out towards you, dotted line going into the page. One bond going straight up here shows it's flat on the page. And then another bond in this direction here, again, flat on the page. So what we need to do is start adding the atoms to our diagrams. All you have to do, when you add an atom on this bond here, add the next one in the same position. So a hydrogen at the top here, make sure you place the hydrogen on this bond here. Next thing, we'll place the chlorine on this bond. So here's our chlorine. Again, we're matching them up as a mirror image. We'll place the bromine on next. So we're now showing, we're starting to be able to form something that is a non-superimposable mirror image. And the fluorine would be attached here. If you look at these two molecules, if you try to place this one on top of this one, you might match up the hydrogens, but the fluorines, the chlorines and the bromines won't match. If you place it on top and you try and rotate the molecule around, when you rotate this molecule, the chlorine isn't going to be coming in towards the page. It will be coming out and facing towards you. Now I can show this with 2 mods. So these two are the non-superimposable mirror images. If you look at the structures, if you match them up, if you put this one in and put a mirror between, this is what you would see on the opposite sides. So if I try and match the atoms up, so I match the green and the orange atoms up here, you'll see that the purple ones will not match up. The white ones do not match up either. No matter how you place this molecule, you cannot superimpose the image on top of each other and have them all pointing in the same direction. So that's what we get when we have a central carbon atom with 4 different groups of atoms attached. Let's just finish up with looking at some more complex molecules, because what they may ask you to do in an exam is look at larger molecules and try and identify the number of different chiral centers that the molecule has. So first example here is cholesterol, and then the example here I'm going to give you is dexamethasone. So dexamethasone is a steroid treatment used for things like treating meningitis, so inflammation. Now, this left-hand one here, so the cholesterol, what we can do is identify the number of different chiral centers where we have a carbon atom with 4 different groups attached. So if we start here, we can see that this carbon here has 4 different groups. We've got an OH group here, so that's 1 group there. We've also got a hydrogen that's here as well, that's not been drawn on because of this skeletal formula. So that's 1, 2, and then if we work our way round, follow it through, we'll get to a different group when we get to this carbon here. So there's a chiral center there, there's 4 different groups around that carbon atom. Again, if we look at this carbon, we've got 1, 2, 3, and then 4 different groups there. So that's another chiral center. We've got another chiral center on this carbon, because as we work our way around, we get to something different. We've got another chiral center here. So we go 1, 2, 3, 4. We're arriving at something different as we go through. Another one here. 1, 2, 3, 4 different groups there. This one is another chiral center. So far we've got 1, 2, 3, 4, 5, 6. We have a 7th chiral center around this carbon, because we go that way, we get to a carbon with a CH3 group in that direction. We go to this one, we get to something different. And then finally, we have another chiral center on this carbon here, because we've got 1, 2, 3 groups there, and then we've got a hydrogen attached. So 4 different things attached to that one carbon. This end carbon here is not a chiral center, because that's a CH3 group there, CH3 group there. So these 2 groups are the same, therefore not fitting up with our rule of having 4 different groups around the carbon atom. So we can see 1, 2, 3, 4, 5, 6, 7, 8 chiral centers in there. Now, if we look at dexamethasone, we can do the same thing again. Now on this carbon, we've only got 3 groups, 1, 2, 3, because there's no hydrogen attached. Where you've got a double bond, again, you're not going to have a chiral center, because you're not going to have more than 3 groups attached to this particular carbon atom. So the first chiral center here, that's the first time we've got 4 different groups attached. So we've got 1 here, we'll have another chiral center there, we've got another one here, another one here, we've got another one on here, one more here, and we've got 1 there, we've got another one here. So we've got 1, 2, 3, 4, 5, 6, 7, 8 chiral centers on this particular molecule. This one here is not a chiral center. We've got 1, 2, 3 groups attached with no hydrogen on here. And again, this is not a chiral center. There's 2 hydrogens there, so it doesn't fit with our rule of having 4 different groups around the carbon atom. So thank you very much for watching. I hope you've enjoyed the video and you found it useful. Please make sure to like and subscribe and share the videos.